Section 1.4 is types of functions and their rates of change. So we're going to be looking at linear functions and also some nonlinear functions and discussing some properties of these functions. First of all, a linear function is represented by f of x equals mx plus b, where m is the slope and b is the y-intercept. I already explained that. You can recognize a linear function because the graph of it forms a straight line. Here we're told that a car initially located 30 miles north of the Texas border, traveling north at 60 miles per hour, is represented by this function. The y-intercept is the distance that the car has traveled. We started out 30 miles north of the Texas border, so our y-intercept right here would be at 0, 30. And then we're traveling at a rate of 60 miles per hour, so the rise over run here to go from one point to another is going to give us 60. So in a linear function, each time x increases by 1 unit, the value of y always changes by an amount equal to your slope. That gives us a constant rate of change. That constant rate of change is m. So here's a table that shows that as x increases by 1 unit, y increases by 60 units. So here's the time. This is our x values right here, the time that's elapsed in hours. And as we increase this by 1, from 0 to 1 is an increase of 1. 0 to 1 is an increase of 1. 1 to 2 is an increase of 1. 2 to 3 is an increase of 1, so forth and so on. You see how as the x increase by 1, from 30 to 90 we have to add 60. From 90 to 150 we have to add 60. So the y's are increasing by 60 each time the x's increase by 1. That constant rate of increase is our slope. A constant function is a function where we have y equals a constant, or f of x equals a constant. And the graph of it is just going to be a horizontal line passing through that constant. So if I were to graph y equals b, if b is positive, I would just have this function right here, y equals b, where b is positive. If b were negative, I would have a function right here that's a horizontal line, y equals b, where b is negative. Less than 0 is negative. The slope of a line we can think of as a rate of change, and how we calculate the slope of the line is we look at the change in the y values divided by the change in the x values. This is a Greek letter delta. Delta in mathematics means change. Across all mathematics courses and even in physics we use delta to represent change. So this just means we look at the difference between y2 and y1 and the difference between x2 and x1. That's the formula for the slope of a line. x1 and x2 cannot be the same, because if they are, then we're dividing by 0, and that's undefined. So the way that we get the slope is just the steepness of the line. I take the change in the y values and I divide it by the change in the x values. This is the change in the x values, this is the change in the y values. We also call this rise over run. If your slope is negative, you rise in a positive direction and then you run in a negative direction. So y'all have seen this before. And I've mentioned this earlier, when you have a positive slope, your line is increasing as you move from left to right. If you have a negative slope, the line is decreasing as you move from left to right. We read a graph like we read a book, from left to right. If you have a horizontal line, the slope is 0 because you don't have any rise, but you have run. So that would be 0 over whatever your difference is in your x values. The slope is 0. A vertical line has a slope that's undefined. We said that a horizontal line has the equation y equals some constant. So in this case, we would say y is equal to 2.5. For this graph, for the vertical line, we say x equals 1.5. X equals a constant. Y equals constant is a function. It's a horizontal line where the slope is 0. X equals a constant is not a function, it's a relation, and the graph would be a vertical line crossing the x-axis at that number that x is equal to. Basically, this means it doesn't matter what x is, it doesn't matter what y is, x will always be 1.5. So I have these points on this graph, 1.5, 3, 1.5, 0, 1.5, negative 3. Notice x is always this constant. Y can be any number you want it to be. Example 1, we want to find the slope of the line that passes through these 2 points and then explain what that slope indicates about the line. We start with the formula for the slope. We have m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I can label these points x1, y1 and x2, y2, and then I just drop these numbers into this formula. What do I plug in place of y2? What do I plug in place of y1? What do I plug in place of x2? And what do I plug in place of x1? Then we just simplify the arithmetic. What's negative 4 minus 2? And what is 3 minus a negative 1? And when we reduce that, what do we get? Negative 3 halves. 2 goes into both of those. Does everybody have a graphing calculator? You might want to get one, especially if you've got to take more math. I recommend the TI-83 or the TI-84. I want to show you what your calculator will do for you. This symbol down here is the negative. I'm pointing at the number by the decimal place. You've got to use that if you want the negative because your calculator interprets the subtraction sign differently. So this will be negative 6 divided by 4. It's going to give you a decimal if you just hit enter, but if you hit math, enter, enter, it will convert that to a fraction. And you can see that that fraction is negative 3 halves. It reduces the fraction for you. All I did was hit math, enter, enter, and it converts the number to a proper fraction. That alone is worth the price of this calculator. Next, you know what we didn't do? We didn't explain what this slope indicates about the line. What does this slope indicate about the line? For each increase of 1 unit of x, y decreases 1.5 units, because 3 halves is 1.5, right? Example 2. The number of gallons of water remaining in a 100-gallon tank after x minutes is given by this function right here. Evaluate g of 5 and interpret the results. If g of x is equal to 100 minus 5x, g of 5 will be equal to 100 minus 5 times 5. And 100 minus 5 times 5 is 75 gallons of water. So after 5 minutes, 75 gallons of water still remains in the tank. You've got a leak in your tank. Part B tells us to find the slope of the graph of g and interpret the slope as a rate of change. Looking at the equation of this line, what would the slope be, the 100 or the negative 5? Remember, y equals mx plus b, where m is the slope. The slope is what your variable x is being multiplied by. So for this problem, what is our slope equal to? Negative 5. And what does that mean in terms of this problem in words? But the equation has to do with water in a tank. We're losing how much water? We're losing 5 gallons of water every what? Every day? Does that make sense? Look at the units of the problems and it'll tell you. The slope is the change in y over change in x. So this is going to be the units of y, which were gallons, divided by or per the units of x. So we're losing 5 gallons of water per minute. I should say per minute. So we negative 5 gallons per minute is one way that you could write it. Next, I want to mention what the zero of a function is. Let f be any function, then any number where that y value is equal to 0 is called the zero of the function. We call this a solution to an equation. If we're solving equations, we always let the equation be equal to 0. It's where the graph crosses the x-axis. It's your x-intercept. It's also a solution to an equation. The zero, it's also sometimes referred to as a root of a problem. Zeros, roots, x-intercepts, solutions, they all mean the same thing. So we could represent the linear function 4 different ways: verbally, symbolically, numerically, or graphically. Where that graph crosses the x-axis is our zero or our x-intercept. Nonlinear functions are what you have when you don't have a linear function. So if a function's linear, it's linear. If it's not linear, we call it nonlinear. Those are the only two choices. The following are characteristics of nonlinear functions. First of all, the graph won't be a straight line. Only linear functions have a graph that's a straight line. It does not have a constant rate of change. It has a variable rate of change. It cannot be written in the form y equals mx plus b, and it can have any number of zeros, not just one. Lines will only have one zero. Quadratics could have 0, 1, or 2 or 3 zeros. So here's an example of the square function. We also call this a quadratic function. This is a quadratic function in standard form. This is the square root function, a cubic function, and then an absolute value function. Later on this semester, we're going to look at how to graph these using transformations. So it's a good idea to memorize what these parent functions look like. But don't worry, I'll go into greater detail when that time comes. In example 3, I ask you to determine whether f is linear or nonlinear and then graph the functions. So in part A, is this a linear function? Remember, linear functions have the form y equals mx plus b. The power on x is 1 in a linear function. This is not linear because x is not raised to the first power. So this is nonlinear. And the graph of this function, you could make a t-chart or graph it by hand or use your calculator. The graph of it's going to look like this. F of x equals 1 minus 2x. Is this one linear? Let's sketch the graph of it right fast. What's our y-intercept going to be? So we only need 2 points in order to sketch the graph of a line. So we have a y-intercept at 1, and what's our slope? So to get another point, I'm going to go down 2 and right 1. And that gives me 2 points that I got from my y-intercept and my slope, and then we just sketch that in using a straight line. On part C, is this linear or nonlinear? X isn't raised to a power, but it's absolute value bars, so this is nonlinear. And if we were to graph this function, we could do it by plotting points, or you could use your graphing calculator. Or later on, I'm going to teach you how to do this by hand. This is an absolute value function that's been shifted to the right 2 units. So our vertex is going to be right here, and that gives us some points, and then we draw the graph. We've just shifted everything to the right 2 units. Rock music share of all U.S. sales. Notice the function right here that represents the sale of rock music from 1988, it looks like, or 1990 to 2006. It's not a linear function because it's not a straight line. Furthermore, these functions, it's decreasing in part of the function. If we read from left to right, our function is decreasing here, then it kind of reaches a low point, and then it starts increasing. Nonlinear functions can change from increasing to decreasing. Suppose that a function is defined over an interval. F increases basically if your graph goes up if you're reading it from left to right. And F is decreasing if it goes down as you're reading from left to right. On this problem, we want to use the graph to identify where F is increasing, and I'll do that in yellow, and decreasing, and I'll do that in blue. Where is the graph increasing? It's increasing from -2 to 2. It's going up right here as you move from left to right. And then it's decreasing everywhere else, isn't it? It's decreasing right here, and it's decreasing right here. So using interval notation, we would say that this graph is increasing on the interval that goes from, and we typically don't include those endpoints because a point is neither increasing nor decreasing. We would just say from -2 to 2, and it's decreasing from, where do I start? -infinity to -2, and from +2 to infinity. You write these answers with respect to the x-axis. On the x-axis, we're increasing between -2 and between -2 and 2, and the graph is decreasing everywhere else. Does that make sense? Yes. Traditionally, we don't use them. I don't know that I would personally count off if you put a bracket there, but we don't say that a point is increasing or decreasing. It's the range of values in between. So this would be decreasing, and this is increasing. With lines, we have slopes to talk about a rate of change, but with nonlinear functions, we don't have a single numerical value that's a rate of change. So what we do is we find 2 points and we find the slope of the line segment connecting those 2 lines, and we call that an average rate of change. So the formula for the average rate of change is actually just the slope formula for any 2 points on that curve. It's just the slope of the secant line. A secant line is just a line containing 2 points on a graph. It has a name, I might as well use it because in calculus we use it. The average rate of change is just your slope formula. And until you hit calculus, you can only find an average rate of change. In calculus, we teach you how to find an instantaneous rate of change. All right, example 5. We want to find the average rate of change from x equals 1 to x equals 3. Well, the average rate of change is going to use the slope formula, which means I need 2 points. I only have 2 x's. That means I've got to start by finding the y's that go with the x's. So if x1 is 1, y1 will be equal to 2 times 1 squared, which is 2, and y2 is equal to 2 times 3 squared, which is 18. So I need my 2 points, 1, 2, and 3, 18. We're going to call this x1, y1, x2, y2, and then we just use the slope formula, y2 minus y1 over x2 minus x1. And we just plug in numbers into the slope formula to get the average rate of change. That's going to be 18 minus 2 over 3 minus 1. 18 minus 2 is divided by, so what we would say is the average rate of change is equal to 8. So it's increasing. The last thing we're going to talk about is something that's called the difference quotient. The difference quotient is what we use in calculus, basically. If I let one point on the graph be x, and then to get to the next point I just add some distance h, I've got 2 points where the x value is x and x plus h. To get the y value, I just plug in the x value into the function, so that if this point is x, the y value is f of x. If this is x plus h, this y value is f of x plus h. Then I just use the slope formula, y2 minus y1 over x2 minus x1. But if you notice, there's a x and a minus x that are going to cancel out. And when I reduce that, I end up with what's called the difference quotient. But it just comes from your slope formula, where one point is x and the other point is x plus h. I think it's easier to understand where something comes from and why it is what it is than to try and just memorize stuff that seems arbitrary and random. So that's why I wanted to point out this comes from the slope of the secant line between 2 points, x, f of x, and x plus h, f of x plus h. Then it's just y2 minus y1 over x2 minus x1, and those x's are going to cancel out. So in the last example, I ask you to find the difference quotient for this function. The first thing I want to do, there's my function f of x. I need to find f of x plus h, so that's where I'm going to start. So f of x plus h is equal to, f is negative 2 times x plus 5, and in place of x I plug in x plus h. Then I want to distribute that negative 2 across there, and that gives me that this is equal to negative 2x minus 2h plus 5. So that's f of x plus h. So then we take that and we plug it into the difference quotient. My difference quotient is this right here, f of x plus h, minus f of x all over h. In place of f of x plus h, what do I plug in? In place of this, I plug in negative 2x minus 2h plus 5. And then we say minus, and in place of f of x, what do I plug in? Negative 2x plus 5. And then this is all over h. Now we simplify. Can I just drop these parentheses? Not when there's a negative right there. Be sure that you distribute this negative. And when I see common mistakes, it's people forgetting to distribute the negative. You've got to distribute that negative across those terms right there. Then I can drop the parentheses. So this is going to be equal to negative 2x minus 2h plus 5 plus 2x minus 5 all over h. Now I've got things that'll cancel out. What's going to cancel out? Negative 2x's and positive 2x, 5 and negative 5, and then that's going to leave me with negative 2h over h. What else will cancel? The h's cancel, which means that this is equal to negative 2. If you do the algebra correctly and you don't forget about distributing the negative and you cancel everything properly, the h's should cancel out. The h in the denominator should cancel out with something in the numerator. So you should be able to finish all of the Chapter 1 homework. That's as far as I think we're going to be able to get today. Although 2.3 is not that long, but I'm going to wait and save it for next week.